We are on lesson 83, multiplying powers of 10, multiplying numbers in scientific notation. So we're just taking what we already know and we are putting it to the next level. So just remember, just your powers of 10. If you have something like 10 to the third power, we know that exponent here means we're going to see that base number 10. We're going to see that 3 times in repeated multiplication. So 10 to the third power is 10 times 10 times 10. We see 3 tens. We know that 10 to the fourth power, we would see 4 tens. Okay. So 4 tens. So that 4 means that's what we see that in repeated multiplication. And remember, this is not repeated addition, it's a repeated multiplication. So this number right here is equal to 1,000. What's cool about powers of 10 is that however many, whatever that number is right there, that's how many zeros you see. You see 3 tens, 3 zeros here. Same thing, we'll have a 1, but then we'll have 4 zeros. And that is the review there. Now, when we combine it together, and if we were to combine these two, if we were to combine 10 to the third power times 10 to the fourth power, that would mean that we would see all of these, because it'd be all repeated, and it'd be 10 to the seventh power. We know that 3 plus 4 equals 7, okay? 3 plus 4 equals 7, and that's how when we are doing multiplying, when we are multiplying our powers of 10, which is really strange, we're adding our exponents. Well, if we look at that, if we were to multiply this right here out, if I were to stretch it out, okay, if that's 10 to the third power, and this is 10 to the fourth power, okay, how many tens do you have? 1, 2, 3, 4, 5, 6, 7. We have 10 sevens. So that's how we get that. And so it's kind of like this. There's 3 tens, there's 4 tens, and that's why 3 plus 4. And that's how you get that. So when we multiply by powers of 10, we really are adding our exponents. Now for the next part, which is multiplying numbers in scientific notation. So here's our problem right here. So what we do for this part is we kind of grab because this really means all multiplication. If we were to take that parentheses now, it really means this. Okay, if we took out all the parentheses, because all it is times across the board. So really what we can do here is we can combine things that are easy to combine. So we can combine these two things. 1.2 times 3. 1.2 times 3 is 3.6. If you did not know that, if you look to the side, it's really 12 times 3 and you put a decimal in place. 2 times 3 is 6. 3 times 1 is 3. You have your decimal, you bring it over once, and it's right there. So 3.6. Then, so we've multiplied these two numbers. Then we take these two things to multiply. 10 to the fifth times 10 to the seventh. Well, we just learned, remember what we do when we have the same base number of 10, we just add our exponents together. So 5 plus 7 is 12. So this whole thing right here simplifies to that right there. And that is how we multiply numbers or problems like this. And notice that it is in scientific notation because that first number right here is in between the numbers of 1 and 9. So, okay, here is example 2. I'm not going to write out the whole thing like I did the last time by putting all multiplication signs. You should just know that that really just means to multiply. So again, I'm going to grab the things that I know are kind of common. We can multiply 4 times 3. 4 times 3 is 12. What we're doing here is we're actually using the commutative property. The commutative property says I can rearrange things and make it easier to work for me. So I'm just grabbing and I'm kind of doing associative property too because I'm putting these things together. I'm really almost rewriting my problem so that it looks like 4 times 3, and then I'm multiplying 10 to the 6th power times 10 to the 5th power. I'm really just rearranging it and then I'm grouping things together. Now you can see 4 times 3 is 12, and then you can see this right here. You can see 10 to the 6th power times 10 to the 5th power. We're going to put our base number 10. 6 plus 5 is 11, and that goes right there. So we just rearranged it and then we multiplied it. Now, we're not done because it's asked us to put this in scientific notation. This is not in scientific notation right now. So we need to move that to scientific notation to make that to 1.2. Remember, 12 to 1.2 would be that to the first power. We bring down the rest of the problem, and then we copy the 1.2, and we do this, times 10, and 1 plus 11 is 12. And this would be our final answer. So remember, when you multiply it and you don't get your answer in scientific notation, you have to make it into scientific notation. Here is example 3. I'm going to do what I did last time, but I'm going to rearrange it and group it together. Oops. So we have 2 times 3, and you might have already seen this. I'm just writing it just so you can really see it and it makes sense to you. So all I've done is I've just copied everything. I've taken the 2 and the 3, I put that together. I've taken 10 to the negative 5th and 10 to the negative 7th, and I put that together. 2 times 3, that's equal to 6. And then 10 to the negative 5th, 10 to the negative 7th. What's negative 5 plus negative 7? Both the signs are the same, so we add the numbers together. 5 plus 7 is 12. We put the common sign in front. Is this in scientific notation? Yes, it's in between 1 and 9. It is in scientific notation, so that is your answer. Example 4. Here's our last problem here for our examples. So we have, again, we'll put things together that are common, kind of regroup them. We're using the commutative property and the associative property. Commutative, we're changing the order. And then associative, we're grouping things together that are common, making them easier for us to multiply it. So here we have 3 plus negative 8, 3 plus negative 8. The signs are different. When they're different, we subtract. 3 from 8 is 5. We take the sign of the larger number, which is 8, is negative. The 8 is larger than 3, so it's negative. Notice here, this is not in scientific notation, so we have to put that in scientific notation. 35 becomes 3.5 times 10 to the first power, because you just had to move the decimal one time. We write the rest of the problem, and then we have 3.5, and then we have 10 to the first power, 10 to the negative 5th power. We have 1 plus a negative 5. Notice the signs are different. When they're different, we subtract the numbers from each other. 1 from 5 is 4. Take the sign of the larger number, it's negative. This is in scientific notation, and that is your answer.